Hey everybody, this is Christian and I'm going to explain why you should stop using VPNs for accessing IT infrastructure. Yes, you heard it right, VPNs aren't really considered that much secure anymore. There's another security concept rising in professional IT these days, and that is just killing it. We will take a look at Zero Trust Network Access, shortly called ZTNA, find out what this new concept is about and what makes it superior to VPNs, and I'm going to show you exactly step by step how to implement this in your network using Twingate, a ZTNA service that's free for up to 5 users and 10 remote networks. That's just perfect for us home lab nerds, and it's also great for corporate environments as well. So thanks Twingate for making this video possible. Let's jump right into it. Okay, so first of all, I want to give you a brief overview of the service Twingate. You can get all the information on their official homepage, twingate.com. There you can find all the product information, the documentation, resources, pricing, and all the other stuff. You can see they advertise themselves as an alternative to VPN, so that's what you typically would use to securely authenticate to any remote IT infrastructure and access internal resources. You can manage servers with it, Kubernetes clusters, web applications, RDP, SSH, basically anything that is somehow network-based. And it's a service that is trusted and used by some respectable and fast-growing companies worldwide. They allow granular access control, lightning fast speed. They have a pretty impressive technology and protocol stack underneath. We will also talk about some of the details here in a few minutes. And yeah, they also integrate well with any other systems that you typically use in professional IT, such as endpoint protections, authentication providers. They support Terraform, Pulumi, NextDNS, and they also follow a least privilege access system. So that means that when using Twingate, you only get access to the resources that you actually need and not just everything. So we will talk about some of the conceptual things, what makes Twingate different than a VPN solution here as well. But I also want to say a few words about this service, because I know some of the people here on this channel, we love self-hosting, and there's always the question here, can you actually trust a cloud service? Can you actually trust a provider? Well, they are a US-based company, but you can see they have a pretty good documentation about their policies, about their compliance settings, and you can see that they are very focused on security. They support multi-factor authentication for any type of resource, even SSH, which is pretty cool. And they also are compliant with their strictest requirements for SOC2, GDPR, and some other enterprise industry standards, which means this is a very powerful platform that integrates well with modern IT concepts. It is completely free for any individuals and small teams, such as home lab people. Yeah, it can replace VPN for remote access completely. It's free for up to 5 users, 1 admin, and 10 remote networks, which is pretty great. And it works on, most of the home lab systems that you would use. It works on NAS, Raspberry Pi, of course, Linux operating systems, and any of the clients that you would typically use, such as iOS, Mac, Windows, Android. These are all supported. Twingate starts with a very strong statement. Yeah, they're saying it's time to ditch your VPNs and embrace zero trust network access by using their service. And that might surprise some people, because we have used VPNs for decades in IT, and VPNs are still considered a very secure system to establish secure remote tunnels between 2 networks. So what is the problem, and why do we actually need to replace them? To understand some of the problems with traditional VPN solutions, we need to take a closer look at how it works. So I suppose this is what probably most of you will know when you have some kind of technical experience with networking. If you want to get access to internal services that are in an isolated or protected network environment, usually that's protected by a NAT firewall or a NAT router, you can't get access directly to these internal services. You deploy a VPN server somewhere in the internal network, and then you need to allow the incoming traffic from your VPN client to this VPN server, usually by using DNAT or port forwarding on your home router or firewall to open a port that the client can connect to the VPN server. And then it can establish a secure VPN tunnel, so all the data in between is encrypted. And from the VPN server, the client can usually access all the resources in your internal network, such as servers, web apps, whatever you need access to. And yeah, so this is how it used to be, or how we did remote access in IT for many, many years. And it's considered a very secure system because the secure VPN tunnel is always encrypted. But there are some problems with this solution, and I want to highlight some of them here. And the first is that you would typically need a static IP or DNS that might be required on your home router / firewall's WAN port, because the client needs a target and a destination to connect to. And that also consequently means that you need to forward the incoming ports on your home router firewall to the target VPN server in your network. So I've marked these yellow because these problems you typically only have in traditional VPN solutions like IPsec, OpenSSL, these kind of things. We have also talked about some services like Tailscale or Zero Tier that kind of work around these two problems here. But there's still a third problem, and this is that as soon as the client establishes a secure connection between the client and your VPN server, it automatically becomes a trusted part of the internal network, because your VPN client will get an IP address, and from there, it's usually able to reach any destination service within that internal network. And I know what some people will say now, well, Christian, that's the whole reason why we're using a VPN, yeah? We want to get access to all our internal resources from outside securely, so what the hell is the problem with that? And this is mostly not a technology problem, this is more a conceptual problem. There are a lot of IT environments and corporate environments operating still based on the assumption that there are two parts of the network. There's one isolated a secure network that is our internal corporate network, where we control all the things. So we deploy the devices, we create the users, we apply security policies and all that stuff. And then there is the dangerous World Wide Web existing, where all the nasty things are happening. So hackers are trying to get access from outside to inside and so on. And when IT environments or companies follow this principle or this assumption, they usually have strong protection policies against the bad networks. So it's pretty hard to get from outside to the inside network. But once you get to the inside network, then there are usually very weak policies existing. And this becomes particularly a problem when using VPNs, because once a VPN client really becomes compromised because of an attack, or because of phishing, because of malware, whatever is happening, it's pretty easy for somebody to move around the internal network. This is also called lateral movement. And this is why we need a new security concept. That is why we need to get rid of this assumption that there are some clients or devices that we can trust more than others. And this is what zero trust is actually about. So one thing that is important to understand, some people think that zero trust means that we never trust anything, but that's actually not true. It only means that we constantly need to verify and check the trust. And this is done based on 3 different pillars. So the first one is a strong user and device authentication. So that means we constantly need to identify the particular user or the device. And this is usually based on strong authentication policies like multi-factor authentication, strong password policies, and so on. The second pillar is authorization, following a least privilege principle. We only give access to something that the device or the user actually needs. Nothing more. And the third thing is we need to constantly check the compliance with security policies. Can we trust the device or the user based on things like, is the device or the client up to date? Has it an antivirus protection installed? Does it have a device encryption or a biometric protection such as Touch ID on Macs, for example? And these 3 things ensure we do our best efforts to protect our network resources. So this is the actual concept, and I know it's not easy to implement all these kind of security policies and a zero trust concept in a company, especially if the network is already existing. You will need to change many things, and you always need to revisit your current security policies if they are following this zero trust concept, or if you need to improve some things, if you need to implement this. And this is where Twingate jumps in, because Twingate is a service that allows you to implement all these 3 things in your IT infrastructure network. Let's have a look how that actually works. Okay, so let's start again with kind of the same setup. We have some internal services that are protected behind our home router / firewall. We have a client that comes from the external network and want to get access to internal services. So we will start by installing the Twingate connector, which is a small application that you deploy somewhere in your internal network from where you can access the internal services. And of course, the client needs to somehow establish a secure connection to the Twingate connector in order to get access to the internal services. But what's different when using Twingate is that you actually don't need to configure anything on your home router or firewall. You don't need to open any ports. You don't need to allow traffic from outside to inside. And it's still handling a secure authentication based on a few different components. And one of them is the Twingate controller. So this is the controlling part. So this is not what you need to install somewhere. This is completely hosted in Twingate's infrastructure. And it's part of the service that they provide. They really have created a secure architecture that always makes sure that the client and the Twingate connector both are authenticated. And then there's the second part, which is called the Twingate relay. So this is important for controlling the data flow and the data streams. This is also hosted in the Twingate's infrastructure, and you don't need to install anything. The Twingate connector will open a connection from inside the network to the Twingate relay, and the client will also initiate a separate connection. This is also the reason why you don't need to open any ports, because the traffic is initiated from the Twingate connector from inside the network to outside, so you only need to allow web traffic from the local network to the external network, which is usually always allowed. And the Twingate relay is responsible for establishing a secure connection between the connector and the client, even through NAT firewalls, without having to configure an IP address, without having to configure a DNAT or port forwarding. It's pretty clever, and it also has some kind of fallback connection, so when for whatever reason peer-to-peer connections are not possible because there are protection policies, for example the home router/firewall doesn't allow UDP protocols for whatever reason, the Twingate relay can also serve as a fallback connection. So then the traffic is always flowing through Twingate's cloud infrastructure, of course, but they still don't have access to the short-lived security key, so they can't really inspect the traffic inside. Anyway, in most cases, the peer-to-peer connection is still possible to establish, and that's, of course, a direct connection between the client and your network based on the QUIC protocol, which is fast, reliable, and that is why Twingate offers such an incredible high throughput and speed. What is also very important to mention is that Twingate also supports many authentication providers. If you paid attention to the website, you probably saw names like Azure AD, Okta, Google Authentication, and so on. So you can easily implement this in your Azure AD infrastructure. And with the Twingate controller, it's always made sure that the client actually, or the user, has actually access to the internal services and resources. So if you want to sign up on Twingate, you can just click on sign in and then usually create and deploy Twingate completely for free. You get a 14 days trial of Twingate Business, and after that, the Twingate starter plan is free forever. And once you're logged in and you created your account, you will get to the Twingate interface. This is where you set up all the things before we can start getting access to our resources. So first of all, we need to add a remote network. You can see I've already added 2 networks here. One that is my home lab network, and the second will be a cloud network that I've not deployed yet, but I'm still working on this. And if you want to add a new network, you can just add it. You can add a location on AWS, Azure, or GCP. But if you're using an on-premise or home network, you can just use on-premise. And then if you go into the network, you can add connectors to this network. One thing that is also important, a network is what is considered a separate part of your environment. And you can add as many networks as you want. So if you have isolated parts of your home lab, you can add a remote network for any of these. But it's totally fine to just work with one remote network, which is your usual home lab network. And once you added the network, it usually starts with 2 connectors, but you can also just use 1. It's definitely recommended to add more connectors to the same network. So this is for high availability and redundancy, of course. Just keep in mind that when you add more connectors, they should be on the same network and they also should be configured the same way. So I'm going to add a new connector here in my remote network. You can see that just creates an empty template. You can, of course, change the name of this. Let's call it connector Demo 1, for example, confirm the changes, and then you can deploy this connector software in your home lab infrastructure using one of the deployment methods supported by Twingate. You can see it has many different ways to deploy the connector. You can use a simple Docker command, a Helm chart. You can use cloud infrastructure. You can also just deploy it on a Linux server if you want, or use infrastructure as code. So I'm going to use the Docker to just show you around. You always need to generate 2 separate tokens here, 1 access token and 1 refresh token for every connector. So these are unique and you should not reuse them for different connectors. Also make sure you don't share them or expose them publicly somewhere. So this is how the secure connection is handled. So let's generate the tokens, and then we can basically just copy these. Okay, so once we have that, we can also customize the Docker command, for example, give it a custom DNS server or enable local network logs and so on. But I don't want to do that right now. It's totally fine to not customize it. And then you can just copy the command, execute it somewhere on a Docker server, and then the container is spawned up and it's connected to Twingate. However, you probably know from all my other tutorials that I love to use Docker Compose instead of just regular Docker commands. So what I've done is I've created a Docker Compose template for the Twingate connector on my GitHub boilerplates repository. There you can find all the other different templates and snippets for deployments of my tutorials. Let's go in Docker Compose. And let's go to the Twingate connector folder. So here's the Docker Compose file that you can use. And you can see it's actually pretty simple. You don't need to configure anything else. So for a short demonstration, I'm just going into my demo 1 server. I think this is a Linux server that already has Docker installed. So let's create a new project folder and let's call it connector demo 1. And let's open this in VS Code and let's create the Docker Compose file. So in this compose file, I will just copy everything from the template, paste it in here. And first of all, I want to connect this to an existing Docker network. So you can check with the Docker network ls command if you have already created a custom network. You can attach this container. Otherwise, it will just create another default network from the compose file. That should also be fine. But I want to connect this to the front-end network. So I'm going to uncomment all of these lines here. And I'm going to change the name to front end. And I also need to uncomment these 2 lines here to connect the container to this existing network. So, and this basically just deploys the Twingate connector Docker container in the latest version. You just need to change a few things. The first one is the Twingate network. So this should be your Twingate network. And what's important, it is not this remote network here. This is also the account name. So let's see creative in here. And of course, we also need to copy the access and refresh token that we've just generated for this connector. Okay, so that should be all. You can also customize a few other things like the log level if you want to see what's going on inside, or if you want to add a custom DNS server. But I don't need any of this. Let's just start the container with the compose up and let's see if it's working. So in the interface, when we refresh it, we should see that the connector is now connected. So this has, just like I've explained, it has initiated a connection from inside my home network to the Twingate server in the cloud infrastructure. And there you can also see the 2 Twingate components that I've explained in the presentation, the controller for authentication and the relay for the data stream. Okay, cool. So let's go back to network. So once we have connected our connectors, we can now start adding our home lab resources. Like, for example, you can see I've added a Proxmox resource, I added a Portainer resource. You can add any internal resource that you like. You just need to give it a name. For example, let's just connect my firewall interface. There you need to select a remote network, and then we can add the address. It can be a DNS name or an IP address. For example, my firewall has an IP address that is this one here, and a port. We can also restrict access to specific ports or protocols. For example, my firewall has multiple services, like it has a web interface, it has an SSH interface for managing the console of the firewall, and I don't want that my users have access to the console. I just want to give them access to the user portal and not to the administrative interfaces. I can just define the port 443 for the user portal and block anything else like UDP, and I also can block ICMP for ping requests. So then this resource only has access to this particular port, and let's create the resource. And now we can also say which users or which groups have access to this resource. I just have created one resource for everyone, so let's add this and see if it works. So now I'm trying to log into my home network using my MacBook, and I don't want to connect my MacBook to the Wi-Fi, so I'm disconnecting from my home Wi-Fi and instead use my iPhone as a hotspot. And now it's like I'm just using my regular phone connection. That is, of course, a completely different network. Now you can see if I want to access the IP address of my firewall on port 443. This, of course, is not possible because the MacBook doesn't have an established connection to my home network. But when I log in using Twingate and I'm now authenticated, I now got access to my firewall user portal. But I can't access the administrative interface on a different port, for example. This is not allowed. And I also can't open an SSH connection to my firewall. Of course, the same does also work for all the other resources. In the Twingate client, you can see what resources your user has currently access to. For example, let's try to open my Proxmox server. I'm just copying the address. And yeah, you can see this is my Proxmox interface. And once I log out from Twingate and I try to refresh the connection, you can see this is not possible anymore. And yeah, so this is how you can access all your internal resources securely from remote networks. But of course, this is only part one, because this is very similar to what a VPN would do, only that we use the least privilege principle. We only give the users access to resources that they should have access to and not the entire network. So the device trust is managed in the devices and policies menu. So first of all, you can see when you click on devices that you can see all the different devices that are connected to your Twingate network. And you can also manage these devices. You can see if they're up to date and if they have security checks in place. For example, my Mac doesn't have biometric configuration or screen lock enabled. But if we go to my MacBook, you can see the biometric configuration. So the Touch ID is enabled and the screen lock as well. And we can use these kind of security postures as a part of our trust policies. So first of all, we need to go into the security tab, and here you can see what different trust profiles you can configure based on the types of operating system. For example, you can see Windows has some other security policies that you can enable than macOS, for example. macOS only supports screen lock and biometric configuration. On Windows clients, you can also check if they have an antivirus installed, a firewall enabled, screen lock, and hard drive encryption. You can, of course, also use your phone to access your Twingate resources. And when you create a trusted profile, for example, let's create one for macOS, something like trusted devices. You can specify some verification requirements. For example, you can also connect antivirus systems like CrowdStrike, Intune. But I'm not going into the details about antivirus integration now. Instead, we could also create the device postures check for screen lock and biometric configuration. And once we added this trusted profile, we need to go into policies, and we can just modify the default policy or create a custom one, for example, trusted policy. In this policy, we can now select our device security profiles, such as only the trusted devices. So that means that all my Macs need to have screen lock and biometric configuration enabled in order to become a trusted device. And I also want to enable multi-factor authentication for the authentication requirements. So that means that only users that have multi-factor authentication enabled on their account and are using a trusted device can get access. And what is now pretty cool, you can configure these policies and security checks on each individual resource. So that means, like, if you want to access the firewall interface, we can edit this and change the default policy to the trusted policy that only users that use macOS with biometric configuration, multi-factor authentication, and so on have access to the firewall users portal. And just like this, you can configure all your resources to really ensure the maximum security and constantly verify if you can actually trust the client's devices and if the user is securely authenticated or not. This, of course, makes your network and your remote access much more secure than any VPN could offer you. So that's the power of the Zero Trust concept. It's not just the technology and the remote access, but it's also the very secure concept of authentication, authorization, and compliance checks with security policies. I'm really interested. What do you think about that? If you're interested to implement this in your infrastructure environment or maybe home lab using Twingate, please leave me a comment if you have any questions. You can also join our Discord and we can talk about that. And yeah, that's it for today. Thanks everybody for watching. I will catch you in the next video. Take care. Bye bye.